Good evening, sir. Good evening, Vishal, sir. This is Neema from COE Chandigarh.
Yes, good evening. Thank you so much for having me here today.
Thank you, sir. Thank you. Thank you for
I have
taking
a
the session.
I have a long association with COE Chandigarh since the time of inception. But though I
Yeah.
have to UAE, so for last couple of years it has reduced a bit. Only I am taking sessions whenever I am in India. So these
Yeah.
days I'm working here as a principal in DPS Ajman. So, and the topic is also an unusual topic, generally not touched during the sessions, during pedagogical trainings, or during the subject specific trainings. But yes, it is one of my favorite topics. And thank you to Miss Anjali and you for fixing my session. And I think, can we start now?
Yes, sir. Sure, sir. We will
I
start,
will
sir.
try. I will try to make a session a bit interactive, right?
Yeah.
So I can see a couple of participants with their cameras on. It's always good to see some faces. Otherwise, it's always a one-way process. So what I'm going to do is, before we start, I'm going to share a link with you, right? Some manipulatives which we'll use because other than history of mathematics, I'm also passionate about technology and teaching of mathematics and these days training teachers for online teaching also. So I request you to, I'm sharing one link with you. I would like to request you to just click on this link and then we will start with our session. So what I can do is I can also share my slide so that everybody can see what is happening. Those who are even unable to open this link, even they will able to see what exactly is happening on the screen. So I'm going to share my screen also. First, I will start with some questions. Now, the first question is, why do we teach mathematics? Now, I want some responses. Those who can, please, those who have clicked on the link can write, they can see on the screen also, and they can write their answers. Why do we teach mathematics? What is the reason? Why do we teach mathematics? And it's a time bounded. You have 30 seconds only to answer. We won't waste much time because it's a limited 1 hour session. Quick responses, 23 seconds. For logical thinking, yes, Ms. Amandeep is saying for logical thinking. To improve more problem solving, creative techniques, right? Agree. And then some is saying that the practical use of subject is there to make students aware about daily, to build logical reasoning, mental ability. Good answers. So we know that why do we teach this subject? But do you know at the same time, over so many years, mathematics is called as language of a universe. Around 4 centuries back, there was a famous mathematician, a scientist also, Galileo Galilei. He said, the universe cannot be read until or unless we learn the language in which it is written. And he said then, it is written in mathematical language. And the letters are circles, triangles, and other geometrical figure. This is a famous mathematical quote by one of the famous mathematician of his time, Galileo Galilei. So that time only he gave justification why we need to study mathematics. So this is the reason why we study mathematics. Now my next question to you, those who have clicked the link, they can do the, I think around 15 people have clicked. So now my next question is, do you think that history of mathematics should be taught to the students? You have 15 seconds to answer. You can say yes, you can say no, or you can also select on can't say. Do you think that history of mathematics should be taught? Your time starts now. 15 seconds, please. 15 seconds to answer. Yes. Okay, I got a couple of responses. Good. 4 seconds, 3 seconds, 2 seconds, and over. So all those who have responded, they agree with me that the history of mathematics should be taught. But at the same time, I come across many teachers who always, they are also right at, to some extent, I'll say that they have limited time and a limited and a course which has to be finished in limited time. So that's why they always find there is a time constraint. At the same time, my experience also says that teachers take very less interest in this topic because there are different reasons. The first reason is that there is no assessment on history of mathematics. There is no question asked in any of the classes or any of the board exams. So they think that why do we need to teach history of mathematics? And then at the same time, history of mathematics is such topic you will not get so much of resource material available with you. I will share the responses, how people have responded. Yes, so you will not get a lot of material readily available. You need to really do a lot of research. But yes, it's very good that NCRT a few years back they came up with a with NCRT when last time when the books were revised. They in every chapter there is a very small paragraph given about a mathematician or a brief history about that specific topic. That was really a good initiative from NCRT. But despite of that, very few teachers and very few students go through those paragraphs. Again, reason is same, that it is not assessed during the examination. And I hope all of you will agree with me. Even many of us as teachers do not go through those paragraph small boxes which are given in NCRT, and nor we motivate our students to go through. Most of us, I won't say all of us, but most of us. But I further would like to justify why do we need to give a little bit of stress at least on this particular topic. Again, I will pose one more question to all of you. And my question is, okay, fine. If we need to teach history of mathematics, can in 1 minute, quickly, I have few responses that if we have to teach history of mathematics, what is the reason? Why do we need to teach history of mathematics? And your time again starts now. Exactly 1 minute for this answer. Why do we need to teach history of mathematics? Okay, yes, good responses. For enhancing their knowledge, correct, to create curiosity. Students came to know how the development of subject took place. Just want to show students how those mathematicians came to the concept. Great, really great. So I liked a couple of answers which you people have shared, and there are some people who have shared answers in the comment box also. I'll go through a few quickly. To make aware about the concept, it encourages us that how mathematician invented the formulas to help to understand the base and origin. So students come to know about origin of mathematical experience, so that students can understand why they need to understand the concept, to aware the students about the origin. Right, great, great. So we got some we have some very good, so we have some very good participants with us who can who are really giving good response, and they are participating also. Another question: when we sit with our family members, especially elders, have you ever in life shown interest in your family history? Have you ever asked your parents or grandparents about their lives or lives of your grandparents? Can you quickly give me responses? Yes, no. Have you ever taken interest in our own family history? Right. So we have all the responses. 100% people are saying yes. They have shown some. They have shown interest in the history of their own families. Now, may I request one or two people to quickly? I'll try to call the names, because otherwise we have many participants, around 50 participants. If they can give me the reason why they have shown interest in their family history. Anybody who would like to reply? I can see Mr. Roy De Silva. Mr. Roy, can you share your experience? Have you ever shown interest in your family history? Yes, please.
Yes, I've just written that I like to know more about my own family. I wrote that down.
Yes. Now,
Hello?
one more question to you. One more question to you. When we listen to stories from our parents or grandparents about our grandparents or great grandparents, how do we feel?
I just feel I belong to a bigger a family tree. I'm not alone.
Yes,
we are part
true.
of an entire web. Yeah.
Exactly. And at the same time, we tend to strengthen the bond. This is what I feel. The bond always strengthens. Most of the students find it as a dry and a difficult subject. But once we start correlating with some stories, then they tend to develop love for the subject. And I think this can be done right from the beginning, right from the childhood. So in my session, today's session, whatever time I have, in this time, I will try to uh, I won't be sharing any presentation with you. So I'm not going to share any presentation with you. I'm going to tell some small stories which you people can use in your daily classrooms, or sometimes whenever you feel you can correlate this story with a specific topic. So I'm going to tell few stories. I thought of not making any kind of presentation because I would like to keep it interactive and more of a storytelling way. I'll do that. But last question, my last question to you, then I'll start with the history, what, you know, for which all of you have joined this session. My last question to you is, can you share the name of your 2 or 3 favorite mathematicians? Yes, please. Aryabhata, Ramanujan, Shakuntala Devi, Aryabhata, Pythagoras, Einstein, Ramanujan, Aryabhata. So a couple of names have come on the screen. Yes. So Pythagoras, Ramanujan, Pythagoras, Galileo, Galilei. Right. So all those names which have come on the screen, I will try my level best to at least touch these names in my today's Euler. Somebody wrote Euler. Euler, do you know, is known as mathematician's mathematician, one of the great mathematicians in the history. So I will touch those. But before that, we will start from the origin. The oldest sign of mathematics which we find on the earth are 35,000 to 50,000 years old. There were notched bones which were found, the bones where some marking was done. And gradually, you know, which shows that how the counting was done at that time. So the bones were used years back, and there were some marking on the bones which was used to represent some numbers, maybe in their language, or counting. And the later version of those bones, gradually, after thousands of years, they became telemarks we use today. Telemarks are used in statistics. The system, when it was introduced, we used to call it bar gate system. 4 bars and a gate to close that bar. Now there is a reason also why 4 bars and 5th gate was used. If I ask you, I will show you how many. You just you just type in the comment box. I will ask you a question. Okay, how many fingers? Okay, most of you have right. So I got the answers. Few answers: three. Some said 4 because maybe because of camera. Yes, but if you try to understand, you did not actually count these fingers. If I again show you how many fingers, if just for a second I'll show you fractions of second without counting, you will say 2. Why? What is the reason? Because our eyes can distinguish between this and this without actually counting. Similarly, not only human beings, animals also have sense of distinguish between small numbers. If there are 4 eggs in a nest and you take out 1 egg, what will happen? Can you imagine how will the bird react? If there are 4 eggs, you take out 1 egg from the nest, what will happen? Will the bird come to know yes or no? Yes. Which means that birds also have sense of counting. But if there are hundreds and you take out 1, it will be difficult. They will not able to know, because our eyes can distinguish between limited numbers. There were civilizations where counting was 1, 2, 3, 4, many. After that, there was no counting. Numbers were discovered years after counting. I will give you one example of Sumerian shepherds around 4000 to 6000 BC. Sumerian shepherds, without having knowledge of numbers were not discovered. They were using one-to-one correspondence to keep track of their sheep. Sumerian shepherds, when they used to take their sheep out for grazing, they were keeping one urn in which they used to throw one pebble. One sheep, one pebble. Second sheep, second pebble. Third sheep, third pebble. So, and in the evening when those herd of sheep used to come back, those Sumerian shepherd used to throw one stone out, and they used to check how many stones are balanced in the urn. Means they were keeping track of their sheep without knowing the numbers. So remember, counting was discovered much before the numbers. So Sumerian shepherd were using one-to-one correspondence, which was later one-to-one correspondence was later used by Cantor to prove the size of infinity. I'll come to that later. So these are the evidences which show that thousands of years back there are traces of mathematics. And if we talk about human civilizations, around 6,000 years back, when people started living around the bank of river Nile, they started doing agriculture. Now, those people, the civilization, they were keeping, they were observing certain patterns. They were always observing that days become night after regular intervals. They were always observing that full moon comes after regular intervals. After a specific number of days, they see full moon. The phases of moon changes, and it's a periodic event. Then also they were keeping track of flooding of Nile. Flooding of Nile was an annual event and was almost a regular and periodic event. And flooding of Nile was also considered as a beginning of a new year. So this is how the old civilizations started keeping track of some regular intervals, and they started studying some patterns. And this is how the people started studying mathematics. Mathematics actually originated from patterns, not from counting or numbers. It started from patterns. So human civilizations were very keen for all these patterns. And then every year when there was flooding of Nile, then the belief in that civilization was that it is the river goddess which gets happy every year. Throughout the year they get water from river, and after 1 year in return they give some portion of their land to the river Nile. So that was considered as holy river, and as a result they started doing the measurements of land. How many portion of land has been taken by river Nile? How much portion has been flooded by Nile? And then when further civilization developed, bureaucracy played a very, very important role in development of mathematics. Taxes were charged, and taxes were charged on the basis of the area of land which a person has. So this is how the development of mathematics took place in earlier civilization, starting with Egyptian civilization. If we talk about Egyptian civilization, now in Egyptian civilization people were using base 10 system for counting, right? So which was basically motivated by 10 fingers on our hand, and they were using cubit, land cubit, which I think you people must have been studying. So basically they were doing the measurements using their body parts, and the base 10 was also based upon 10 fingers in our hand. But in Egyptian civilization there was no place value system. To count million, there was one single symbol which was used to represent million. But if we subtract 1 from million, then there were 54 symbols which were used. And Egyptian people were keeping their records on the leaf. And one very famous leaf is, we call them papyrus. Rind papyrus is one of the very famous. I will start asking you a question. Who discovered Pythagoras theorem? Can you quickly write in the comment box? Who discovered Pythagoras theorem? Yes, Greek god Pythagoras, Pythagoras. Okay. The Greek civilization originated much after Egyptian civilization. Now, my question to you, Pythagoras. Thank you so much for quick responses. Yes, this is what we study, but it is a debatable topic again. The pyramids of Egypt, when the pyramids of Egypt were made, do you think that pyramids of Egypt, such a great architecture can be made without knowing a right angle triangle and the Pythagoras theorem? Yes or no? Quickly, yes or no? Can pyramids of Egypt, do you think pyramids of Egypt could have been made without knowing a Pythagoras theorem? No, 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 no. Okay, thank you so much for your responses. Now, listen. The pyramids of Egypt, there are evidences that when pyramids of Egypt were made, the Egyptian people, they were aware that if we take 3 knots of rope on one side, 5 knots on second side, and 4 knots of rope on third side, means if we take knots of rope, 3 knots, 4 knots, and 5 knots, they were aware that they will get a right angle triangle, which means Egyptians used Pythagoras theorem. So at one point or the other, so which makes it controversial whether Pythagoras was actually a person who discovered Pythagoras theorem or not. Egyptians were also aware of the formula to calculate volume of a pyramid. But there was a problem with Egyptian system. One problem I have already discussed, there was no place value system. Second problem was there was no system of proof. Every problem was done using some concrete numbers. So proof, there was no culture of proof in Egyptian mathematics. And after Egyptian mathematics comes Babylonian mathematics, and which we have evidences about 2500 BC. Now, Babylonians were using clay tablets to write. Clay tablets were used. We have one very famous clay tablet. The evidence is there. We call it as Plinkton 322. And do you know that there is a question in mathematics in grade 10 where there is, in which there is a square and there are 4 circles? How many of you know? Yes or no? A mathematics question in grade 10th mathematics, a square and there are 4 circles in that square. That question is related to area. Yes, yes, yes. And do you know that question was found on that particular clay tablet which I was mentioning, Plinkton 322, around 2500 BC. So that question is very, very old. And Babylonians, first I discussed about Egyptian, second Babylonian. Now Babylonians were using base 60. How many of you are familiar of base 60? We use it in angles, we use it in time also. Yes, yes, yes. Okay, thank you so much. Base 60 system was motivated with 12 knuckles on one hand. These 12 knuckles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 5 fingers on other hand. Right? So 12 into 5, 60. So this is how the base 60 system was motivated, base 60. Again, counting, Egyptians were counting, 10 fingers, but Babylonians were counting 60. 12 into 5. So this is how they were, their system of counting was motivated, basic 60 system. They were also the first ones to give the calculations on calendars on the basis of cycles of moon. Cycles of moon they were using to make calendars. And about 800 BC, we have the evidences that Babylonians, they had the record of eclipse. And the first ever quadratic equation, the evidences are that Babylonians solved first ever quadratic equations based upon the area of a rectangular field. So this was all about Babylonians civilization. And the third civilization about which all of us know more is Greek civilization. We study about Greek mathematician. We hardly talk about Egyptian civilization. We hardly talk about Babylonians. But we do talk about the Greek civilization and Greek mathematicians. One more question to you now, quick question, and I want a quick answer. Do you know who is a first known mathematician? First known mathematician? Quick response, please. Any guesses? Do not worry about a wrong response. Don't worry. Quick response. Aryabhata, Subramaniam, Aryabhata. Okay. Bhaskara, Aryabhata. Aryabhata. Most of you Aryabhata. Now I will clarify it. The first known mathematician was Thales. He was a Greek mathematician. Aryabhatta was somewhere in 5th century. Aryabhatta was born somewhere in 5th century. But Thales was the first known mathematician from Greek civilization, and he was. We also study about Thales theorem. I hope all of you are aware about Thales theorem. We teach Thales theorem, and he did a lot of work on geometry. There is one very small instant story I will tell you, which you people can use whenever you teach your students. Once Thales was walking and he was watching night sky. He was walking and he fell into a ditch. And there was an old lady who was watching, who was just observing what is happening. The person is, looking at the sky and fell down in a ditch. That old lady started laughing. And she started making fun of Thales. She said, if you do not know what is happening on the earth, how can you tell what is happening in the sky? And Thales was one of the first person who gave the exact prediction of eclipse. Though eclipse calendar was made earlier also, but there was the calculations were not precise. There is also a story. I hope all of you must have heard of a story of a donkey with the salt going through the river. Yes or no? Yes. Okay, good. In some texts, it is written that story is a true story and is related to Thales, though there is no evidence. Some people say, yes, that story is related to Thales. So Thales was a mathematician who was there in that story. After Thales, the second known mathematician, Greek mathematician, is Pythagoras, who was born somewhere around 495 or 500 BC back. And he formed a school in Semons. And do you know the name of the school is very, very interesting. He named that school as the semicircle. The semicircle. But Pythagoras was also one of the most controversial mathematician. There is a school of thought which believes, that maybe Pythagoras himself did not discover anything. Because in the school of Pythagoras, whatever discovery was made by any person, it was named after Pythagorean. That's why we study Pythagorean triplets. So, and Pythagoras it was not only a school, it was considered as a religious institute. Pythagoras was worshipped. Somebody wrote in the beginning that he was Greek god. He was not exactly Greek god, but he was worshipped like a god because of the respect in his school and the culture in his school. But there is another story that for him, he said that the numbers are like God. And there was one Pythagoras disciple, his name was Hipparchus, who discovered first irrational number. Hipparchus was the first mathematician who discovered irrational number. But for Pythagoras, he did not tolerate it, and ultimately he killed his disciple. He drowned Hipparchus in the sea because the laws were very strict in his school, and there was anybody who who was not following the law at that time was punished severely. So Pythagoras, that's why Pythagoras is considered as a most controversial. Another reason is he killed his disciple who discovered first irrational number, root 2. Actually, Hipparchus was working on a square with side 1 unit. And when he was calculating the diagonal of that square, he found that he cannot express the diagonal of a square in P upon Q form. And a number which cannot be expressed in P upon Q form is known as irrational number. So when he was very excited, he went to Pythagoras, but Pythagoras' reaction was totally different. He did not accept it. He said no. And he killed his disciple. So this was a story of a Pythagoras, but at the same time, there is evidence that Pythagoras was first mathematician who studied the relationship between mathematics and music. Once Pythagoras was going and he passed where a blacksmith was beating iron, and he found that the sound has some, you know, some kind of pattern. Then he started studying on music and mathematics, and then he proved that there is a relationship between music and mathematics, and he was the first mathematician. So credit is given to him. Third Greek mathematician is Plato, who was also a philosopher. For Plato, he was the one who discovered Platonic solids, five regular symmetrical figures called Platonic solids. And Plato also worked in the field of geometry, and according to Plato, that geometry was the key to unlock the various mysteries in the universe. So that was work of Plato in the field of geometry, and he was a philosopher. We all studied about Plato in our, I think, in Beard. There were some contexts related to Plato. Then another fourth Greek mathematician, who was, I will say, who was the greatest among all, he was Euclid. And today we study Euclidean geometry. And Euclid was one who brought mathematical revolution. He wrote books. The names of the books were Elements, and there were 13 parts of that, 13 volumes, you can say, of that book. And the main work was on geometry, even on algebra. He used axioms to prove certain theorems, and that happened for the first time. Certain axioms were used to prove theorems. And he was the first mathematician who gave the formulas of cone, formulas of cylinder, and other 3D figures. And he also worked on perfect numbers. And then his work on navigating sea and measuring time was also famous. And Euclidean geometry is one which we still study today, and we teach Euclidean geometry in our schools. Though, as a mathematics teacher, we should know there is a school of thought which is not in favor of Euclidean geometry, and people say that in the universe there is nothing which is plane. In fact, the Earth is not plane, so that is a different thing. But still, Euclidean geometry is applicable, and it's taught in the schools and in the curriculum across the world. So after Euclid, the last mathematician which I'm going to mention, though there were a few more Greek mathematicians, was Archimedes. We know Archimedes as a scientist more than a mathematician because of his buoyant force and work on buoyancy. And again, story of Archimedes is famous, that he discovered buoyant force, and then he came out of a bathtub and calling Eureka, Eureka, Eureka. This story is famous, but do you know that Archimedes was killed while solving a mathematical problem? Yes or no? Quick response, because in between I will take your responses also. I repeat, Archimedes was killed while solving a mathematical problem. Simranjeet Kaur knows it, and very good. Good to hear. Isha also knows. Good, good. No. Okay, fine. So I'll tell you what exactly happened. Amandeep Verma, thank you so much for your response. Yes, Sapna Sharma. So I'll tell you a small story. Archimedes did a lot of work on areas of regular figures. In the field of geometry, again, he worked. At the same time, Archimedes made weapons of mass destruction against Roman soldiers. So there was a fight between Greeks and Romans, and Archimedes made weapons of mass destruction. And how he made the weapons? He made some big concave mirrors and focusing the sunlight, he used to burn ships of Roman soldiers. So this is a small story of Archimedes. He against Roman soldiers, he played an important role, making weapons of mass destruction. But what happened once he was on a seashore, he was solving a problem probably related to circles. Some text shows that he was solving a problem related to circles. just on the seashore in the sand, and Roman soldiers came, and Archimedes told them, please wait, let me solve this problem, let me finish this problem, then I will fight with you. But Roman soldiers never waited for him, and they killed him with the sword, and this is how Archimedes was killed while solving a mathematical problem. So we discuss about a brief history of Egyptian mathematics, then Babylonian mathematics, then Greek mathematics. The greatest contribution out of all was Greek mathematician, because Greeks gave us power of proof. Whatever proof of all the theorems we do in our schools, the origin is from Greek mathematics, from Greek civilization. So the credit goes to Greek people for giving us the power of proof. After Greek civilization, there was mathematics developing in different parts of the world. I will talk about then, Chinese civilization. I won't talk much about Chinese civilization because I'm already, during this COVID period, the whole world is suffering. I won't speak much about Chinese mathematician, but when Great Wall of China was made thousands and thousands of years back, Chinese were aware of mathematics, how much calculations, they were very good at calculations, about how much material is required. So all these calculations they used to do. And then Chinese mathematicians, they also were a bit superstitious. For them, odd numbers were males, even numbers were females, and there were some numbers to be avoided, some numbers which they used to consider as, you can say, good for them. So they were a little bit superstitious. The emperor used to have a panel of mathematicians for him to solve various problems. Astronomy was studied during those days. So it was there in their culture. Then the magic squares which we study today basically came from Chinese. Now there is again a lot of difference of opinion in belief in the different parts of the world. There are different parts of the world where people think that Indians, their mathematics developed when there was a trade relation between China and India, whereas in actual Indian mathematics is right from Vedic civilization, Vedic mantras. Then in 3rd century BCE, Hindu-Arabic numeral system was used in 3rd century BC. So we can justify and we can, debate that Indian mathematics was not taken from Chinese. Somebody spoke about Aryabhata. I will give a little bit brief about Aryabhata. Aryabhata was 5th century Indian mathematician, and he was the first one who gave a very close value of pi. According to him, value of pi was 3.1416, and he found the circumference of Earth also, and very close to exact value. Now, what Aryabhata did, Aryabhata decided a time when there was a 90-degree angle between Sun, Moon, and Earth. He found that when the angle between Earth, Moon, and Sun is 90-degree, then one of the angles of right angle triangle is 1/7 of a degree, 1/7 of a degree, which shows that one side of that hypotenuse of that triangle is 400 times side. And this is how he gave a very rough figure of the distance between these celestial bodies. So he did a lot of work on trigonometric functions. He did a lot of work on sine functions, and the value of pi was also given. And there is a belief that zero was also discovered. Now we are short of time. I'll touch just I think few more points on Indian mathematics. Now zero was discovered in India. This is accepted universally in all the countries. There is no controversy behind it. Why? Because there is an evidence. There is a temple in Gwalior, and the walls of that temple, the inscription shows that the zero was first used and discovered in India. But at the same time, we should know, again, there is no solid evidence, but the belief is why the symbol of zero is almost circular, if not elliptical, you can say. Why the shape of zero is this? Now, there is a belief that people used to do the calculations, Indians, they used to do the calculations with pebbles and with stones. And when they used to pick up a stone, then nothing is left and nothing is zero. And the kind of depression which we get in the sand is almost the shape which we use exactly today. So this is a belief how the shape of the zero was discovered. And Brahmagupta, somebody wrote Brahmagupta was first mathematician. No, Brahmagupta was 7th century mathematician, and he was the first mathematician who gave us the properties of zero. He was the first one who said 1 plus 0 is 1, 1 minus 0 is 1, 1 multiplied by 0 is 0. But Brahmagupta made one mistake. And the mistake was, he said 1 divided by 0 is 0. And that mistake, which he did in 7th century, was corrected by another Indian famous mathematician, Bhaskara too, almost in, you can say, 12th century. In 12th century, Bhaskara too corrected this mistake. He said, no, any number divided by 0 is not defined. It cannot be 0. So this is a very brief history of Indian mathematicians. Then I will talk about one more Indian mathematician before we wind up. The trigonometry, the branch of trigonometry originated from Greece. Greek mathematicians originated. But actual development of the subject took place in India, starting from Aryabhata. There was one mathematician from Kerala. Very few people know his name. His name is Madhava. He was the first mathematician who gave the value of sine function of each degree. Greeks were able to find sine function of only limited values, but Madhava was the first one who used infinite series to get the value of each and every angle, sine function of each and every angle. This was a brief, very brief history of Indian mathematicians. If we go in deep, there is a lot more to say. Limited time, but here another great contribution of Indian mathematics. The negative numbers were given by Indians. Brahmagupta only gave the negative numbers, concept of negative numbers. And basically it started from the loan which people used to take in the society. And now the Indian mathematics was to be taken to the Western world. How Indian mathematics went to the Western world? There was a mathematician in the Middle East region, a Persian mathematician, we call him Muhammad ibn Al-Khawarizmi. Muhammad ibn Al-Khawarizmi was a great mathematician who wrote a book called Al-Jabr. Al-Jabr was a book written by him, and from where the name algebra was originated. Algebra came from Al-Jabr, Al-Khwarizmi's book. Al-Khwarizmi's reference is there in our NCRT also. I don't know how many of you have read, but it is there. And he took Indian. That's why we call it as Hindu-Arab Hindu-Arab numeral system, because of the contribution of Arab mathematician. They studied Indian mathematics system. They took it to the next. They compiled actually from different civilizations. Major contribution India civilization, and this is how they took it to the Western world. So we call it Hindu-Arab numeral system, and Al-Khwarizmi is a mathematician behind it, and he is also known as father of modern algebra. Al-Khawarizmi is father of modern algebra. Father of geometry was Euclid. Prince of mathematics is Carl Friedrich Gauss. And so I talked about brief ancient history of mathematics and a little bit Indian contribution. There was a lot more to be shared, but because of limited time, there was a mathematician, Descartes, Leibniz, Newton, Euler, and I think if we have another session sometime, we can discuss it. Or can I take few more minutes? COE Chandigarh, 5 minutes we have?
Yeah, sure, sir, sure.
We have 5 more minutes?
Definitely, sir. You can take 5 to 10 minutes more. No, it's not an issue,
All
sir.
right. Now I will talk about. Okay, fine. I will talk about. I cannot talk about all mathematicians, but if you write one or two names, I can speak briefly about those mathematicians. Anybody who wish to write, please type. You want to know about Leibniz. You want to know about Rene Descartes. You want to know about Newton. You want to know about David Hilbert. You want to know about any other mathematician. You can write. Euler. Ah, yeah. Isha Gag. First response is Euler. Okay. Newton, yes, yes. So two mathematicians, Carl Friedrich Gauss. I will try to at least touch these two, three mathematicians, right? Starting with yes, starting with Newton. I think we will start with Newton, and then because Newton and Leibniz story is interrelated. Now, Newton was British mathematician. He was from England. uh, we know Newton more than a scientist than a mathematician because of his discovery of the laws of motion, gravitation. But Newton did some groundbreaking work in the field of calculus. We all teach calculus. He discovered calculus. Mr. Shashank, I will agree with you, but there is another side of a story. Newton discovered calculus. He was a mathematician from England, but there was a parallel mathematician from Germany. His name was Leibniz. Goldfield Leibniz was his name. German mathematician. He also discovered calculus parallel to Newton. Now, Mr. Newton in 1676, year 1676, Newton wrote one letter to Henry Oldenburg was his name. Henry Oldenburg in Germany. And Henry Oldenburg did not understand what was that letter about. Newton gave a very brief coding, he did not talk about calculus, but in a coded language, he mentioned something about calculus. Now that letter, Henry Oldenburg passed on to Leibniz after 6 months because he didn't know what to do with this letter. He had no idea what was written in the letter. So when Leibniz received that letter in Germany, after 6 months, Leibniz was also working on the same principle. Leibniz promptly replied to Newton, but Newton did not reply back to that letter from Leibniz because of his ego and his status which he had. But Leibniz, he published his first account of calculus in 1684, 1684. Leibniz published calculus. And there was a family of famous mathematicians called Bernoulli's family. I don't know how many of you have heard of Bernoulli's theorem. Bernoulli is one family which produced generations and generations of mathematicians and scientists. So maximum number of scientists and mathematicians were produced by Bernoulli. So when Leibniz published the account of calculus, then Bernoulli family supported Leibniz and they spread the word around in the world of mathematics and they praised Leibniz a lot. But Newton was very hurt. Newton was not ready to give Leibniz the credit. After 20 years of what Leibniz published, calculus, in 1704, Newton published a book on optics. And in that book, as a, what do we call, as an appendix to that book, Newton gave his account of calculus and Newton said that the idea was stolen by Leibniz. Newton said that I wrote a letter and 6 months Leibniz worked on it and then he stole my idea and he discovered calculus. Then there was a big fight between Newton and Leibniz. But Leibniz was a positive person. Leibniz's reply was, this is not a fight between this is not fight between Mr. Newton and me. This is a fight between England and Germany because these were rival nations. So this is how he took it. But then case was moved to Royal Society of England, and where Newton himself was a part of Royal Society. And the judgment came in 1714, 1714. And in that judgment, it was written that Leibniz was first to publish the calculus. It was first discovered by Newton. So credit was given to Newton and Leibniz was held responsible for plagiarism. Leibniz went into depression and he died, I think in 1718 or 19 he died, and 1720, after 9 years, Newton also died in 1727 around. And in 1727, somebody wrote about Euler also. And the year Newton died in 1727, the same year, Euler became famous when he solved the first problem. Euler was probably 17 or 19 years old. In 1727, Euler solved a problem which was published in a French mathematical journal. The problem was how to arrange mass on the ship, and he used his mathematics to talk about that problem. And this is how Euler started getting popularity, and we call Euler as mathematician's mathematician. He was such great mathematician. He was a Swiss mathematician from Switzerland. He was born in Switzerland. But Euler had a very rough life, means there were tragedies and tragedies happened with Euler. Euler had 13 children, out of which only 5 survived. Euler's wife, after 40 years of marriage, Euler's wife died in a fire accident. But Euler, he survived. Anyhow, he survived from that accident. And Euler also lost his eyesight in last years of his life. But do you know what was Euler's response when he lost his eyesight? He said, now I will be more focused and I will have less distraction. That was Euler's passion for mathematics. Euler was a mathematician who solved very old problem known as 7 bridges of Königsberg. And Euler worked in St. Petersburg. Then Euler also had a rough phase when he came back and he worked with a king. King gave him a problem. King wanted to have fountains in his courtyard. Euler was given a task to design it. Euler was a pure mathematician. He ignored the friction between water and the fountains, and the disaster happened. He could not design the fountain, and Euler was, he had to face a lot of criticism at that time. Then he further, in last days, he went back to St. Petersburg, where he died after. Euler's work was published even 50 years of his death. And that was Euler's history, 18th century mathematician. And we have 1 minute. I'll talk about Gauss. Somebody wrote about Gauss. In 1801, Gauss started getting popularity in 1801. The year when scientists, they discovered 8th planet. They discovered 8th planet on a New Year Eve. And there were celebrations and celebrations in Germany, in mathematical and science community. There were celebrations that a new planet has been discovered. But after a few days, the planet vanished. Actually, that was not a planet, that was an asteroid. It vanished. Few months later, Gauss announced that he knows where is that planet. And he did some calculations, and he told mathematicians and scientists, he told scientists to focus their telescope in a specific direction, and the magic happened. They found the planet back. And this is how he started gaining popularity. Gauss was born in Göttingen, we call it Makkah and Medina of mathematicians and scientists. He did a lot of work in statistics. We talk about Gaussian curve. We talk about the bell curve that was given by Gauss. Though he was very poor, but right from childhood, he was a great mathematician. We call him Prince of Mathematics. There are other stories also. You must have heard of a story of sum of n natural numbers that was also given by Gauss. Then he found some patterns in prime numbers. A lot of work he did in the field of astronomy also. Now, I think due to lack of time, we will wind up the session here. Now, quick feedback, if you can write. I hope you came to know a little bit about mathematical world, and a little bit more. This was a different. This is a different kind of topic, which is not taken by the resource persons and is not taken by the mathematics teachers also. But I hope that you enjoyed, and it was a bit different from your regular courses on pedagogical concepts and your courses on your sessions on specific mathematical problems. So this was all from my side. If some other day time will permit, I'll be happy to share a bit more what I know, a little bit knowledge what I have, because I have a little bit of passion of studying about history of mathematics. History is a very vast topic. More you study, more you come to know. Still, whenever I open any book of history, then I think I do not know anything. So really, it takes years and years to study. But if I'll be able to answer your queries, I'll be happy to do that. Please, any queries from your side if you have. Okay, thank you so much. My pleasure. Give my regards to Miss Anjali and COE. Right?
Sure,
Thank you.
sure, sir, sure. Thank you so much, sir. Thank you.
Thank you so much. Okay.